Okay, a little homework help for 6-1. A polynomials, adding and subtracting. So this first part's going to be just talking about what polynomials are and some of the terminology that we use for them. So let's do just a couple of these, maybe number 2 and number 4. So identify terms, coefficients, and degree. So for each polynomial, list the terms, coefficients, and degree of the polynomial. So like for number 2. So what are the terms? So it's sometimes easier to sort of frame these in a table. So what are my terms and the coefficients and the degree of the terms and the degree of the polynomial? The degree of the polynomial. This is how we did it in class. Okay, so number 2. So the terms, we have 4y squared, negative 3y, and 6. So make sure those signs get carried along with each term. What are the coefficients of each term? So we got the coefficient here is the number beside the variable. So we got a 4. We have a negative 3, and we'll just call 6 the coefficient there. There's not a variable there. I mean, I guess you can say it's y to the 0. We don't normally talk about coefficients of just constant terms, though. So degree of terms. So what is the degree of each term? So the degree is the exponent of the variable. If you have multiple variables, which I don't think I gave you on this one, it's just the combination of those two. So degree of the terms. So we're going to have 2. Then we're going to have, what's the degree of this one? Degree of 1, and that's degree of 0. These are normally written in descending order. This makes it easier to read these as you're going through and working with them. Now, the degree of the whole polynomial is the highest degree, so 2. This is the second degree polynomial. And why is that important? Different degree polynomials behave differently. So even polynomials behave differently than odd polynomials, just in how their graph and their behavior, their long-term behavior. So what about number 4? I'm going to have to have another sheet for this. Very similar. Let's make out a table. So terms, the coefficients, degree of each term, and then the degree of the whole polynomial. Okay, so what are my terms for number 4? So negative 3m cubed, 4m squared, negative 2m, and 11. Now what about the coefficients? Negative 3, 4, negative 2, and again, kind of calling 11 a coefficient. The degree, we're looking at these terms right here. I mean, each term's exponent. We have 3, 2, 1, 0. The degree of the whole polynomial, we just look at the highest one, 3. Hope that helps on that little part. So like terms versus unlike terms. So circle or list the like terms in each set. So let's see what we got here. Actually, all of these here are like terms, right? These first 4. Like terms have the same variable with the same exponents. So these are all squared. Can't combine that with that. So there's number 6. Oh, how about number 10? When we have multivariables, we won't do a whole lot of these in here, but it's good to sort of know. So we got y squared z. Do I have any other y squared z's? I sure do. So here I've got these guys, and there's another y squared z. So all I'm focused on is the variable and the exponent. They match. Okay, so number 11. Rewrite each polynomial in standard form, then state its degree. So standard form, we're just writing in descending powers. So how about number 12 and number 14? For number 12, now start with the highest power, which is to the 4th. So make sure you keep that negative 9y to the 4th. Cross that off. And then next power is this minus 5y squared. Cross that off. Plus y, cross that off. And then plus 3. Then how about number 14? Let's look, what do we got here? 5m to the 4th. And then we've got an m squared term, so minus m squared plus 7m minus 3. So not super hard. We're just rewriting this so that these are in descending order. Okay, so 6.1b. So here we're going to be adding and subtracting these polynomials and then evaluating polynomials. We've kind of done evaluating before, we just didn't call them polynomials. So combine like terms. Oh, let me just do number 2. So the parentheses here don't really bias anything, right? So we can, in a sense, just ignore them because we're adding. So we're going to have 4y cubed plus 3y cubed is going to be 7y cubed. And then negative 2y plus 1y is a negative 1y. And we normally don't put a 1 for a coefficient. You can if you want. I would not count off. And then 6 plus negative 5 is plus 1. That's it. Adding polynomials is generally one of the easier things, particularly compared to exponents, which we've done earlier. Subtracting polynomials, however, maybe I'll do number 5. Subtracting polynomials is a little trickier because we need to distribute this negative through. So I recommend writing that step out. So we don't need the parentheses on this first one. So 4y cubed minus 7y plus 2y. And then distribute this negative. And we've done that before with distributive property. Minus y cubed plus 3y plus 5. So really be careful on that. Now, it's up to you. When we were combining like terms earlier, I said that it can be advantageous to go ahead and write those like terms side by side. I'm going to do that on this one, but don't think you have to do that. It does come out a little bit easier mentally, but you do have to write down the problem again. So 4y cubed, what is this like term? Minus y cubed. And then I've got I have a typo here, or a righto. It should not be a 2y. So minus 7y plus 3y. And then I've got plus 2 plus 5. Okay, so now I've got my like terms. 4y cubed minus, I'll pencil in or pin in a 1y cubed is 3y cubed. Then a negative 7y plus 3y is a minus 4y. 2 plus 5 is 7. Again, this step here is an optional step that you do not have to do, but I recommend it early on anyway. Okay, and so, we can extend that to if you have more than just 2 polynomials, right? Maybe I'll do number 9. So I've got a minus here, so I've got to be careful. Now you can do 6a squared minus 3a squared. That's going to be tricky, especially on this one here, when we have the negatives. So really be careful on that. I'm going to pull this up over here just for lack of space, and I'm going to rewrite everything without, hopefully I can squeeze it in. Let's start over here. 6a squared plus 2a minus 1, don't need those parentheses, minus, here we got to be careful, 3a squared plus a minus 5. And then there's a plus, so I don't really care that much about it. I'll just go ahead and remove those parentheses and rewrite what's in the parens. Okay. Again, we have an optional step, but I'm going to recommend it and I'm going to do it. So all my like terms are going to go side by side. So 6a squared, I've got a minus 3a squared, and I've got a minus a squared. So I'll just go ahead and remove those from my list there, then move over to the next term, the a. I've got a plus 2a, a plus a, and a plus 4a. And then I've got a minus 1, minus 5, minus 2. All those go away. Okay, so now my like terms are all beside each other. Here's our first set. Okay. So 6a squared minus 3a squared is 3a squared, minus a squared is 2a squared. 2a squared. And then move on to the next set. My a terms. So 2a plus, I can pencil in a 1a, is 3, plus 4 is 7. And here you got to be careful. Got a minus 1, let's do plus a negative, plus a negative. So I've got a negative 1 plus a negative 5 is negative 6, plus a negative 2 is minus 8. A lot going on there, but it was all just arithmetic is the hardest part. And this here was the hardest part, I think, making sure you're subtracting right. Be careful on those. Now, part D, we've kind of already done. So then maybe this actually should have been up here, distributing that negative sign. Maybe I'll do 10. I'm going to distribute that negative on each of these terms. So I'm going to rewrite that first one, nothing going on there. And then minus 2x squared plus 3x minus 7. Now, again, we can write those like terms side by side, but let's see if we can do it without doing that. So 3x squared minus 2x squared is just a plain old x squared. Those go away. Negative 4x plus 3x is just a minus x. And I've got 5 minus 7 is a minus 2. I've got a lot of mixed practice here. I don't think I need to do any of these. These are all the same as the ones that I've been doing before. Definitely ask in class if any of these show up that you need to see. But evaluating a polynomial for a given value, super important that you can do this. And we've been doing it before, so I don't think there's anything new. I'll just do one of these. How about we do one with a negative? 25. So x cubed minus 2x squared plus 5 when x is negative 1. So I'm going to pop a negative 1 in wherever I see an x. So negative 1 cubed minus 2 times negative 1 squared plus 5. So negative 1 cubed. I know since it's an odd exponent, this is going to be negative. Minus 2 times negative 1 squared. It's squared, so I know it's going to be positive. Plus 5. Negative 1 minus 2 times 1 is just 2, so 2 plus 5. I like doing plus a negative. So now I've got negative 1 plus negative 2 is negative 3. Helps, you can write it out. And 5 minus 3 is 2. All right, and all these here are the same. Just be careful when you're evaluating. You can definitely use a calculator on these. Just make sure you know what you're doing. And that's it for that section. Hope that helps.